A unit rate is very useful to compare costs of the same item in different quantities. Because the cost cannot be compared by the packaged amount, use the unit rate of each to do a comparison. So here's an example where we're comparing 3 different sales for paper towel rolls. We have the first is 1 roll for 99 cents. The second deal is 8 rolls for $7.76, and the third deal is 9 rolls for $10.44. So the question becomes, which one should you buy? What is the best deal? So what about these 3 different sales are similar? How are they different? Is there any kind of pattern you might be able to see? I'm sure you've seen this all over the grocery stores and the supermarkets. They do this all the time. They try to actually get you to pay more money, but they market it as a better deal. So we'll be able to compute and compare the products using the unit rates and make sure we're not fooled and get a good deal and use and spend our money wisely. The best way to do it is to set up a table where we're looking at the number of rolls, which we already know that information is up front. We have 1 roll versus 8 rolls versus 9 rolls. But if we look at the total cost and we divide by the number of rolls, we can see that unit rate, that cost per roll, and see which one we should buy. Filling in the information, if you divide 99 cents by the 1 roll, you're paying still the 99 cents per roll. But if you take the total cost of $7.76 and divide by the 8 rolls, you're paying 97 cents per roll, which is already better than deal A. And if you look at deal C, the third deal, you're taking the $10.44 and dividing by the 9 rolls, which actually gives you $1.16 per roll. So the best deal is actually the second one, deal B, the 8 rolls for $7.76. So without the unit rates, it might not be that easy to see, and you might be going for sale A or C instead. But now with this information, you can buy the best deal. Another example of looking at rates and comparing products is the order of your ratio, right? Seeing what's important. For example, a store was selling 8 mangoes for $10 at the farmer's market. Keisha said, that means we can write the ratio 10 to 8 or $1.25 per mango. Lewis said, I thought we had to write the ratio the other way, 8 to 10, or 0.8 mangoes per dollar. Can we write different ratios for this situation? Explain why or why not. What is similar about Keisha and Lewis's thinking? What is different? Is one a right answer and is one wrong? Or is it okay to write 10 to 8 and 8 to 10? The answer is actually yes. This context can be modeled by both 10 to 8 and 8 to 10 and their associated unit rates. The context itself actually doesn't determine the order of the quantities in the ratio. We were just told that the store was selling 8 mangoes for $10. There's no questions that's following. So we usually choose the order depending on what we want to know in the future, really what the question would be. But here it's more of just a statement. So the ratios are true whether it's 10 to 8 or 8 to 10. The order only matters once you have a question. So here's an example where we have actually 4 different questions. So here we're comparing the amount of miles and minutes that a runner is having for their run. We have a runner ran 20 miles in 150 minutes. If she runs at that speed, let's look at each of these questions individually. First, we have if a runner ran 20 miles in 150 minutes, how long would it take her to run 6 miles if she runs at that same speed? So if she's running at that same speed, we can use miles per minute. So we have 20 miles for the 150 minutes. So that is going to equal, for 6 miles, some unknown amount of minutes that we have to solve. So you can look at your common factors between numerators and denominators. You can use cross multiplication. I'll model that here. where 150 times 6 would give you 900. 20 times x is 20x. So if you think of what multiplies to 20 to get 900, you get your answer of 45. So that's why we can fill in the table that it would take 45 minutes to go the 6 miles. You just have to make sure your order here was miles over minutes, so the 6 miles over the 45 minutes. For part B, she's still running the 20 miles in 150 minutes, but if she runs at that speed, how far could she run in 15 minutes? So again, if we have miles over minutes, that should equal, well, now we don't know the miles, that's our unknown, but we know the 15 minutes. So we can again cross multiply to solve for that unknown value. 20 times 15 gives us 300. And then we have 150x, 150 times x. So what number multiplies times 150 to get 300? That's where we get our answer of 2 miles. So we can fill in the table 2 miles for 15 minutes is that same speed of 20 miles for 150 minutes. Part 3 is asking how fast is she running in miles per hour? So here, you have to be careful because miles per hour, her rate is in miles per minute. This 20 over 150 is miles per 150 minutes. So we just have to be careful and recognize and remember that it's not going to be over 1. It's going to actually be some amount of distance over 60 minutes because there are 60 minutes in an hour. So we can solve this by cross multiplying. 20 times 60 is giving us 1200. 150 times x is just 150x. And we can think what multiplies to 150 to get 1200. If we're doing that problem, we get our answer of 8. So we can fill in the table that 8 miles is for 60 minutes, which is that 8 miles per hour. Finally, we can ask, what is her pace in minutes per mile? So now minutes per mile, that is our unit rate because it's 1 mile for how many minutes. So here we want minutes per mile, so we have to actually use the ratio 150 over 20. We can then divide by the denominator of 20 to get that unit rate, which gives us 7.5 over 1. So that's why the runner's pace in minutes per mile is 7.5 minutes per mile. It's a unit rate. So when you have these rates that are given, you just have to pay attention to what the question is to see how you should compare the two and write your initial rate and ratio so that you can solve the problem matching up with the equivalent ratios and the equivalent units, right? This was usually the other 3 parts we were doing miles per minute. Here, you have to do minutes per mile because of the question.